So let me just do a little bit with the AI tools, so that I don't neglect this entirely. And I guess let's see. Um, the CoA Physics Tutor. I don't know how much time, additional time I'll spend this semester. So it is something that's available to you. It's at this short link. You can follow the link. It's basically a custom GPT, custom version of ChatGPT. And one of the ways you might use it is, let's say you are working through the homework set, and there's some question that you are struggling with, like one of the projectile motion questions. Then you can use this to try to answer. And um, in the past, I used to do this demo with just copying and pasting the question, and at least last semester when I did it that way, it kind of misbehaved. It gave me like confused responses. So I assume with the 5.2 thinking it'll still do the same thing. Assuming it does that, I will give you what I recommend that you do. So this custom GPT, it has two advantages over the regular ChatGPT products. One is that I gave it my lecture notes. So it has information that's specific to this class, which will matter when we start doing forces and what I call standard strategy. If you ask regular ChatGPT what is a standard strategy, it has no idea. But if you ask CoA Physics Tutor GPT, then it knows what standard strategy is. That's one advantage. And second, it's more of a, I guess, what I might call guardrail. So, with the AI, it's so easy to abuse it. Ask it a question, it answers it fully. You sometimes you are trying to use it in a good way, so you try to read it through, try to understand it, and oftentimes you're trying to use it in good faith, but how much you think you understood when you read something is different from how much you actually understood. So with the regular ChatGPT, even if you're trying to read through the answer and understand it, oftentimes simply reading it can mask how much you didn't understand. So with the CoA Physics Tutor GPT, it's been set up so that yeah. So it's gotten this far. It's set this up. It's told you, okay, split it into x and y, write the kinematics equations, and then do all this. And it's done some of the setup for you. It told you the origin that it's gonna use. It told you where the green would be, launch angle, and then it showed you this, or at least told you how it'll break velocity into components, and it told you the projectile equations we'll be using: the horizontal component with no acceleration, and the vertical component with the acceleration of minus g. And then it stopped here. No regular ChatGPT 1. Maybe if you use the study mode, then it'll stop. So this is the second way in which this is the guardrail. So it stops here and asks you either this question or your turn. Use this to try to do that. And my recommendation is try it. And if somehow that gives you the full final answer, great. Then put your answer in here, and you can move on. Or if you still get stuck somewhere, then you can ask a follow-up question. I think that's a way in which generative AI can actually be good as a virtual tutor, because it can respond to you in real time. You are always welcome to send me messages. I love answering your physics questions. I'd love to answer them. Not many people ask me questions. But with the Canvas messages, it's never gonna be instantaneous. Even though I do try to answer pretty quickly, it'll probably take me a couple hours, and because I need to be in front of a computer. And if you come to my office hour, then it's instantaneous. But I don't have office hours 24/7. So that's a ChatGPT. I don't know how much more work I'll be putting into this, either improving it or testing it this semester, unless there are some requests from people. What I want to play with this semester is actually NotebookLM site. And I gotta figure out some way to do this smoothly. Maybe I will, because right now I'm logged in as an owner of this thing, and I don't know. That's not really the best demo. Um, so, okay, I'm gonna do this on my oops. Let me clean this in my other screen, and let me copy and paste that in here, and let's see, switch the account to my personal account. Oh, maybe I could use my Berkeley account for this. Oh, never mind. Because it's an organizational account, it says I don't have access to NotebookLM there. On my personal account, it is also actually an organizational account, but it's my organization. I control it and I have access. So I think this is what I was testing it the last time. So I'll figure out some setup so that this transition is smoother next time. So this NotebookLM site, you go there, you can see the sources. So it actually has the entire semester's material already. That's what these lecture transcripts are. This is the lecture transcripts for all 30 lectures. So if you look at it, yeah, I think there's so you can scroll all the way to the end where that's like I don't know. This is not really optimized for viewing, so it doesn't work all that well here. But yeah, there's that. So it has the entire semester already. What these other sources are, so if you select simply these two, and ask a NotebookLM question like. Using the two sources selected, can you give me sort of a 5-point summary of the course? I mean, summarize a 5-unit, 16-week class into 5 points. But I mean, it's I guess if I actually put effort into, I can kind of give it an attempt. I would say standard strategy, that's a big one. Use of conservation laws, that's another. And the skill of setting up system of equations and then solving system of equations, that's 3. And then I can come up with 2 more, like rigid body motion. And yeah, so but you can do that. Kinematics, I actually don't care that much, although mathematical maturity is an important part of the learning here. And yeah, standard strategy, yep, there it is. Conservation laws, yep, both Gemini and I agree. And I was about to say, rigid body motion, yeah, that's the one. Yeah, it's basically giving you the units of the semester. So yeah, you can definitely do that. It again has the source for the entire semester. And when I was generating mind maps, that's when I kind of realized when I'm generating assets in the studio, with most of the assets, it actually lets me customize the prompt. Like with the infographics, I can, here, is there a custom prompt? I wonder if, I might not have any custom prompt for any of them. But with most of the media, it lets me do custom prompt. But with mind maps, for some reason, it doesn't let me. So the only way I can generate mind maps where it's not gonna try to do the entire semester, and when it does, it'll necessarily I think it limits how much depth it goes into. So when I try to do mind map for the entire semester, the level of detail it goes in is necessarily gonna be different from when it's mind map focused on a particular week. So kinematics is this week, right? So if I look at kinematics portion of the mind map, that's for the entire semester, then this is the level of detail that it shows. With the that's the level of detail it shows with the kinematics portion of the mind map. When the mind map itself was generated on the entire semester's material, like this much breakdown. And I suspect if I go to the mind map that was generated specifically for this week, let me look. And if from the titles and the order it's not clear which one it might be, then this note on mind maps is the note that I wrote to kind of spell it out. So I think this was for week 1. It's a little bit wonky. I got kind of confused by table of contents. This is week 2. So this is the kinematics material, principles and frameworks of classical kinematics. So I go find that mind map, principles and frameworks of classical kinematics. And when I look at this, yeah, it's actually a little more detailed. Kinematics in 1 and 2 dimensions. There's talk about motion along straight line and kind of breakdown of those. So in order to generate this more detailed mind map for a given week, what I had to do was limit the sources. So it's based on the 2 sources, and the 2 sources it's based on are, I'll go back to the sources pane. It's so let me go back to the sources pane. It's these 2 sources. The source for week 2. So lecture transcripts for week 2. That should be lectures, I think 2 and 3. And I can double check. That should be lectures. I think there's there's a table of contents thing, because not having that really tended to confuse AI. It like hallucinates to try to fill in the gap. But when after you scroll through all the table of contents, then yeah, it starts with the lecture 2. And if you scroll past to where the next lecture is, then it should be like lecture 3. Oops, did I go too far? Yeah, this is not optimized to view this way. But week 2 lecture transcripts and week 2 textbook chapters 3 and 4. Now, if we are using the mind map in a way I'm going to demonstrate right now, you have to kind of make sure that you go into sources and select the ones you want, because otherwise, one of the features that I saw with the mind map is you can use it to basically start a new chat item. As you look at this mind map, you can use this as a way to kind of review. You read it through the textbook, you watch the lectures, and then now you are trying to kind of test yourself. Did I get everything? So you look at, okay, kinematics in 1 and 2 dimensions, motion along straight line. You look at position, displacement, it makes sense. Average velocity, instance makes sense. Average acceleration, instantaneous deceleration makes sense. And maybe as you're looking at it, you look at two-body pulse problems and you're not sure where did that come up. Maybe you think, I don't remember that. If you're mostly remembering lectures, that actually would make sense. I don't think I actually lecture on it. I think there's a textbook example on it. So one of the ways in which you can use mind map is if you click on this, that'll start a new chat. Now, as I click on it and start a new chat, discuss what the source say about two-body pulse problems in the larger context of constant acceleration. This chat simply uses whatever sources are selected at the moment. It doesn't actually go back to the sources that the mind map is based on. It simply uses whatever sources are selected. So you have to make sure that you select the relevant sources first before you use the mind map in this way to kind of have NotebookLM summarize what's there. So based on provided sources, represent step up in complexity, coupled motion, two-body pulse, coupled, and these are the sources with the basics of. I'm pretty sure. Let me click on it. Source guide. Yeah, it's going to the textbook. So yeah. Is there a way to? I guess I'll just look at it narrowly. Sorry, I gotta. Two-body pursuit, discussion of how these problems are contextualized, core concept, textbook defines, and then I think it's gonna go through the rest of catch condition, and then this is still the textbook, I think question for the gazelle and the cheetah. It's a. I think this is one possible way someone could use this AI tool to make sure you didn't miss anything, like reviewing mind map. people can do it pretty quickly, and then as you recognize something, as you see something that you don't recognize, this can be a time saver. AI will tell you where in the course material that was mentioned, and this entire thing should be the textbook again, because I, as the lecturer, I remember not lecturing on two-body pursuit problem. So yeah, I guess that's probably all the time we have for the demo this week. I'll try to think of different things to demonstrate. I think last time I generated this kind of podcast item, and I guess maybe it'll take a minute. So let me do this. I generated it specifically in an interactive mode. So let me play it and let me kind of show you what that interactive mode means. So I'm gonna make sure that I share my audio so that you can hear what's gonna be playing, and I hope my own audio will work. Let's see. So let's see. Does it have permission on? Hopefully it'll ask for my permission on interactive mode. Let me start playing.
We move through the world every single day. We walk to the coffee shop, merge onto the highway, toss an apple core into the trash can.
Hopefully making the shot.
Hopefully. And we do all these things completely automatically. But we rarely stop and see about, hey there, want to share your thoughts on this?
Okay, I need to allow while visiting. Hi, long-time listener, first-time caller. Can you tell me about the two-body pursuit problem? I don't remember that from the lectures. Where is that coming from?
Hey, welcome.
We love having you join in.
That is a fantastic question.
And it touches on a crucial concept.
The two-body problem, specifically the
planetary two-body problem.
Which is what we think you mean, is
absolutely central to the later lectures.
It's the mechanism that Newton
used to explain Kepler's laws.
We were going to talk about that
much later when we...
Oh, yeah. Go on.
Sorry, I don't mean two-body like orbital problem. I mean two-body pursuit problem. I saw that in the mind map for this week, and I don't remember seeing that in lectures.
Thank you for the clarification.
That is even better because the two-body pursuit problem is actually introduced much earlier.
Right. It's one of the foundational problem-solving strategies from the Kinematics section.
You are absolutely right to point out that it's in the source material. It's mentioned as the next level of complexity in kinematics.
We actually see that term show up explicitly in the university physics text.
Yeah, that's where they define it.
It's where the motions of two separate objects are coupled.
That means the unknown you are looking for depends on the motion of both objects at the same time.
Think about a...
Yeah. So I don't know if this is really a thing for me. I don't know if I would learn from something like this. But if it is for you, so I did this as a kind of demo. You have a discussion in the class where you can use to kind of request additional items to be generated. Hey, request it, and I will generate it for any other chapters that people might want. So I think that's all the time we have for the demo of NotebookLM for this week. I will think of something else to demonstrate next week, maybe. We'll see.